there are two important factors for any lunar base. One is being able to communicate with Earth. If you're out on the far side of the moon, currently there's no way to send any radio signal around the edge of the moon and back to Earth. You have eventually we'll be able to do that with orbiting satellites of some sort. And maybe early bases will be able to set up those satellites first, but at least right now, the near side seems to be a better place to be. And if you can communicate directly with Earth, you can build a big antenna on the moon, you can have very high bandwidth communications that might be limited if you have to go through a satellite. So being on the ground and being able to see the Earth directly does have that advantage. And the second factor is having access to energy. There are obviously lots of proposals for powering a lunar base, and people talk about nuclear power as an option. The big problem on the moon with solar power is, in most places, the lunar day is as long as our month. It's 28, 29 days. And so there's a 14-day nighttime period. And if you're relying on solar power, you have to store that energy for 14 days, which makes for huge amounts of energy storage. Now, pretty much anywhere you need some batteries or something to store power for a while. But the longer the period is, that just multiplies the mass requirements and other requirements for that sort of storage. So having continual sunlight allows you to have power all the time, allows you to do the processing of materials and so on that you would need to do to expand your base beyond where it originally was located. And from those two conditions, basically, there's one location, or a couple of locations on the moon that seem to be ideal, but one in particular, which is something that's a high altitude place at the poles, because at the poles, even though the moon rotates so slowly, it's almost its rotation is quite different from the Earth's in that it's almost vertical relative to the plane of its orbit around the sun, so that the polar locations don't have long periods of nighttime as the poles of Earth do. So there is a location here which is outlined in the green box. This is an image of the south pole of the moon. It was made from a composite of images from Clementine. I think some other images, but it's Clementine was one of the recent lunar orbiters that was actually a Department of Defense project that produced some very valuable information. It was the first mission to the moon from the United States since Apollo 17 left in 1972. It went in, Clementine was in the 1990s, and there was another lunar prospector later in the 1990s. So the two missions to the moon we've had since there's the year.
My apologies, somebody missed me off to church.
Well, that's a good excuse. All right. So I'm going to speak for just about the poles, and then if you have some material about the why not the poles, and
Oh, sure.
we'll get to that. Okay. So this is the little spot outlined in the green rectangle is at least what David, well, Malapert Mountain. And that's their ideal location. The little kind of star on the peak, the idea is that you would put solar panels on a tower going up right at the peak, and then that would rotate around as the sun goes around. And we pretty much have continual sunlight on that, about 80 to 90% of the time. And then from there, it's not actually quite at the South Pole. The South Pole is where it's labeled misspelled Shackleton. There's a crater there, and there's a variety of other interesting places nearby. factors there is because of the way the sun shines at the poles of the moon, there are these craters which are apparently always dark. They never see the sun at all. They're so deep, and the sun comes in at a very low angle that they never get any sunlight. And water has been detected, or at least hydrogen has been seen from the Lunar Prospector mission and Clementine. Saw some evidence of it in those polar craters. So these dark craters are also they're very cold. So the idea is that probably comets have come in and had volatile materials like water and methane and so on, and have deposited those materials and left them frozen in these dark craters. Those dark craters are also ideal for an infrared or a good quality telescope. Infrared telescopes require very cold temperatures, and it's already cold. And Roger Angel, who testified before the Senate last year on this, had some sort of proposal for a telescope that's a very large liquid mirror telescope that could be situated in one of these craters and would be way better than anything we've got now. So there may also be, in addition to hydrogen, there may be carbon and nitrogen, which aren't present in other areas on the moon in very high quantities. The other advantage is in other parts of the moon, the temperature varies between night and day by up to 400 degrees. In the polar areas, since it's pretty much continuous, the temperatures, at least in the summit areas, are pretty steady at about minus 30 degrees on the surface. So you wouldn't have problems with the materials changing with the temperature change. And since it's obviously this Melter Mountain is on the Earth side, but if you just go a few 100 kilometers or so in the other direction, you're on the far side, and that's an interesting area in itself because you're completely shielded from any radio from the Earth on that side. That's a good place for radio astronomy. There's also some interesting geology there. The Apollo missions, for the most part, landed in flat places for good reason. And this is mountainous. This is islands, and we don't have samples. Certainly from this area, we don't have samples of actually what the minerals are. There's a lot of guesses that the geologists have, but it would be really nice to know. There's also an enormous basin, the largest impact crater in the solar system right there. Actually, the South Pole is right on the edge of it, and it extends onto the far side, about 2,500 kilometers from one side to the other. And there's a lot of scientific questions about that. When did it form? Did it actually go deep enough to get to the mantle of the moon, which might be different materials than the surface? The basin is also known to be richer in iron than other highlands, so it's different highland material even than it is on highland. Lunar highland rather than the Mare type on the near side. And so we should be able to use the materials there. That's a false color image of that basin. The South Pole is this area right around here, and then it extends, as I said, a diameter of 2,500 kilometers, a good fraction of the diameter of the moon there. From that angle. That's an altitude map from Clementine, so the purple is very deep down. The depth between the highest point and the lowest point is about 12 or 13 kilometers. So it's a very, very deep basin. And there's some of the imagery that, at least as far as they can tell from this sort of spectroscopic stuff that's being done, They think there's a lot of iron, kind of a high concentration of iron in the basin area. Now you'll see there's a black spot there where the pole is, so we're not quite sure what it's like right at the pole.
What's the scale bar on those? Is that 1.5 or 15?
15%, yeah. Yeah, there's pretty substantial concentrations. And titanium also is there. Some quantities that are higher than the surrounding highlands, although the titanium seems to be more in the northern part of the basin rather than in the polar area. So this is more on the iron and titanium content. The cross is where the average of the South Pole 18 sample. Well, we don't have any real samples, but at least the estimate is. So about 10% iron and a relatively small percent of titanium. As compared to the red on there, you'll see is the Mare basalt region on the near side. Well, there are some Mares, small ones on the far side as well. But those have concentrations of titanium that can be really very high, and also higher iron content. But it's not that bad. Okay, it's not all roses at the poles. And I'm sure Peter will expand on this. We are talking about landing on a mountain. That's if you don't have some way of preventing yourself from falling down a slope or something, you may land and then end up somewhere different than you wanted to be. And it may be hard to get around. If you've got a flat surface, it's a lot easier to move around than in a mountainous area. On the other hand, it's the moon, and the gravity is a lot lower, so maybe it won't be so bad. You don't have access to those Martian materials. There may be some lava flows in that basin, but they're probably not close to the South Pole area. So probably none of these lava tubes that might be ideal for settlement. It is a little bit more expensive with energy to get the poles, although you can do it from the L1. If you have a base at L1, that's your stopping point is pretty much the same as anywhere else on the road from there. The sun being close to the horizon, it does give us light continually, but it makes it a little more complicated to gather that light because it's just coming in at a very low angle, so your solar panels have to go up rather than be flat on the ground. And of course, the light isn't there all the time. So this is just the last slide. It's showing us this again. And the yellow lines here now are, this is from, I think it's a diagram from David Schrank's book, The Moon Resources Future Colonization. It's Schrank, Burton Sharp, Bonnie White, and Matthew Zangola wrote this book a few years ago. And they envisioned a network of railroads, it's the yellow here. Lunar railroads that connect different areas in the polar region. The stars, the different stars are more solar power powers that gather energy. So this is, as you develop, you can envision a base expanding. The little blue dots, I think, are supposed to be bases here. You can envision a base expanding from the initial location out to a whole network of infrastructure on the South Pole. And so at least it seems like a possible way of enabling a growing lunar settlement. Thanks. Okay.
No, maybe I might ask you to put some up.
I have a question. Well, when having the sun that low to the horizon create problems with just looking around the scenery. You can't look at a segment of the
I'm going to get to that. My name is Peter Koch, and I'm editor of Luminar's Manifesto for the last almost 18 years. I respect the people who are exploring the idea of a lunar base at the poles. However, I disagree with them To me, the whole rush to the poles is based on fear. Fear of the lunar night. Something that 2 weeks of night, continuous night, that we'd have to find some way to get through wherever else we might go instead of the poles. The lunar axis is not quite straight up and down. It's tilted about 1.5 degrees, which means if it was a perfect sphere, in order to get sunlight at the poles all the time, we'd have to have a tower a couple kilometers high with rotating solar panels. Now, apparently, there is a mountain, Mount Malapert, at the South Pole, and now there seems to be some place on the crater rim at Perry at the North Pole where different parts of the peak and crater rim are sufficiently high above that ideal plane, ideal sphere, that they are exposed to sunlight through a bigger part of the month. At Mount Malapert, I think it's what, about 86% of the time, 84%. The trouble is that's not 100%. So that means we still have to have a nighttime power storage system. Now, if we have to develop it for 30% of the night, why not develop it for all? If we have to install solar installations at various different points of a mountain and lay cables out to collect the power in the grid, the amount of material that we have to bring up to install this solar collection system may be heavier than the amount that we could need to use to just install a power storage system so that we could get through the entire night. So I'm not sure that we are saving anything by going to the poles. There are a lot of people who would be happy with an outpost on the moon. We're there, good. Little America too, on the moon. And that's the end of it. That's all they want. I'm someone who wants to see lunar settlement using the resources. You know, there are people who want to go to Mars because Mars has more things than the moon does. It has more hydrogen and carbon and nitrogen, more water. It has a bright sky instead of a black sky. It has a day-night period closer to ours. And the moon doesn't have that. The moon has 3 things that Mars doesn't have. Location, location, location. You stop and think of Japan. Japan never had the resources to become a great nation. It had brains, and it developed markets and access to those resources. I see the moon as the Japan of the solar system. Now, on the moon, generally we have 2 types, broadly speaking, of regolith. The Highland regolith, which is richer in aluminum, magnesium, calcium, and the Mare regolith, derived from basalt, which is higher in iron and titanium. Also, there are the creep rare earth elements, potassium, phosphorus, which are found mainly on the near side, on the splash out from the Mare Imbrium event. And we're talking the South Pole Aitken Basin may have some exposed mantle deposits, and scientists are very eager to get at those and take a look at them. Well, that's not the only place they exist. The thinking is that large craters with central peaks, those central peaks are upthrust mantle material. So we may have access to that anywhere. Given the two broad types of lunar soil or regolith, it would seem that the ideal place to have a settlement would be along the Highland Mare coast, where you'd have ready access to both suites of materials. What about hydrogen? Well, there is solar wind hydrogen in the topsoil or regolith, but there was solar wind over billions of years. There's not much. 10,000 tons of regolith will yield you maybe 1 ton of hydrogen, and well, combine that with the oxygen, you've got a lot of water. If, whenever we handle regolith, your bulldozers, whether we're making a road, whether we're gathering material for a processing plant, whether we're gathering soil that we're going to transform into gardening or agricultural soil, whatever we do, if the equipment that handles it has also equipped to heat it up, extract the gases, separate them, and store them, we will always have enough hydrogen, enough helium, and other useful things. I know that we've all been concerned before Lunar Prospector that, the hydrogen, you gotta have water. Actually, the thing on the moon that is most efficient in terms of how much we're going to want of it is nitrogen. That's the pinch point. How much nitrogen we can access. If we can't access much, we're going to be in buildings with short ceilings because we can't afford the nitrogen for the air, for the buffer gas. But there's nitrogen in the soil too. Water, ice. It now appears that it's not just at the poles, but there is a significant amount of permanently shaded areas in craters of 20 kilometers or more in size, as far away from the pole as 30 degrees. What I am thinking of, do we have a map of near side? Near side Maria. There's one up here called Maria Forest. That's the closest Maria to either pole. Here you've got the Alpine Valley. North shore here, Maria Forest. 2 craters further away from the pole with significant ice deposits. We're talking 200 miles. North, from the South Pole to the nearest Mare coast, 1,300 miles. Some people want to think that ice and hydrogen is so important that that's where we ought to be. Well, Los Angeles is in Southern California. It's not in Prudhoe Bay. in northern Alaska. Just because we need a resource just doesn't mean that that's the ideal place to put a settlement. If we need 1 million tons of hydrogen or water and need a billion tons of iron and titanium, which is easier to ship where? We do need to go to the poles. We do need ground truth landers which can see, dig into the soil and see what percentage of moisture there is there, how hard it is to drill and extract, whether, and most importantly, whether it's just water ice or there are carbon and nitrogen oxide ices as well. Given that the origin of this ice reserve is from comets, most likely. The comets, let's say there's a scenario. A comet happens to hit the moon at a spot which is currently in darkness during the night, vaporizes, and during the night some of that moisture manages to settle over permanently shaded areas near the poles before the sun comes up and this solar wind drives it away. And over hundreds of millions of years, this collects there. Well, if the source of this moisture, this endowment is from comets, we expect, carbon and nitrogen ices too. But we have to determine how easy it is to access. We might find, this stuff is very cold. It might be very brittle and hard. It might be quite an operation to mine it and extract it. We don't know if that's going to be simpler or easier to do than just harvest out the soil where it is everywhere. Other things that bother me about the pole site is we mentioned that the sun comes in parallel to the ground. We don't have a bright sky, so you don't have ambient lighting. That means the shadows are ink black. Now you can imagine the terrain in front of you. Look, streaks of light and long streaks, blotches of darkness. Even a slight, depression is going to be ink black. And from day to day, that pattern is going to change. You are not going to recognize where you are one day from the next because of this. I think it's going to be a very dangerous place to operate. They want to go to a mountain. The terrain there is going to be rugged. I don't know if that's good. To me, this seems like something they're going to do, but not right away. It seems to be dangerous. David Schunk is an avid Lunar railroader. Well, I have been also 10 years before I heard of David. So we've exchanged many ideas. More, fortunately, we can't fly around. The railroads make a lot of sense. There are some challenges. You have to figure a way to handle heat expansion of the tracks. And I've got some ideas on that. That's a totally different subject, and I think it makes sense. We're going to see them wherever we need to move great masses of material regularly, freight. And when we have multiple settlements, if they're close enough and a lot of traffic between them, we might find there. Whether we'll have maglev or not depends upon whether we can find a high temperature superconductor that can be made of lunar materials. Right now that We haven't found that. That would solve a lot of problems. Imagine you're an alien species and you are used to a climate that only varies a few degrees, let's say above your comfortable temperature. And you're looking at Earth and you say, aha, this one Pacific atoll, it's got just the right temperature. We can't go anywhere else because we freeze or we bake and we don't know how to handle that. So they go there and they say, ha, we've explored Earth. It's sort of ridiculous. And this is where I think we're headed when we go to the poles. Well, we're afraid of the night. We can't get through 15 days of darkness. Here we don't have so much darkness. Let's go there. Well, isn't this like the moths flying around the lamppost and eventually dying? So again, I respect all these people who are calling for polar sites, and there have been advocates of polar sites for a long time, at least 20 years to my knowledge. But to me, it just, the advantages to me are somewhat illusionary and don't make sense. What do we want? An outpost on the moon? Even if we want only one, I'm not convinced that that's the easiest place to go. Because I said we still have to have a nighttime power system. That's going to weigh something. But so is any system that collects sunlight at various points around a mountain and then collects it in the cables and everything, whatever is involved in there. That might give away more than the power system. And when it comes to nighttime night-span power systems, there's various ways to go about it. During the day, you can collect excess solar and use that excess solar to set yourself up for the night. Your water reserves, if you have wastewater in the process of treatment, well, you can electrolyze that and then at night span run it through fuel cells. You could use one scheme I've seen is to use solar concentrators to melt the soil and collect it in magma pits underground and use the heat, for steam or whatever. There are many schemes. Of course, the simplest one is just to have a mini nuke. And actually, I think that's what NASA's going to do anyway. Whether we advocate or abhor nuclear power is not the point. It's a good thing to have, but we need to have backup. And as long as we've got excess all solar we want during the day, it makes sense to collect extra to store some of that power for the night. And regardless whether we have a nuke or not, simply because we also have solar during the day span, it makes sense to try to organize our operations and schedules so that we're doing the bulk of energy intensive, maybe labor light operations during the day span, reserving the bulk of energy light, manpower intensive things for night. Not every kind of operation can be neatly divided like this, but I think that's one of the things we will be doing. And you know, when you have a break in your schedule like this, 2 weeks this way, 2 weeks that way, that sort of breaks up the routine. And I think we'll have a pace of life that reflects the cycles on the moon in this way. To have a base on the moon, you know, one site the world does not make. We're going to be eventually having outposts at many places, because even if we say take up Maury Island coast, where we have access to both Highland and Maury materials, and also along the Maury coast is where we find lava tubes. So we'll have storage, shelter, which would be ideal for industrial parks, for warehousing, and perhaps for emplacement of the grand archives of all mankind. There's no place safer in the solar system than a lunar lava tube, which has already been intact for 3.8 billion years. And there's none near the poles. Closest ones would be in Maury Figueres. We're used to mining ores, which are rich concentrations of materials, and ores have been collected through millions, hundreds of millions, billions of years of geological processing in the presence of water. That's never happened on the moon. Things are sort of homogenized. And what we have to do is something we don't know how to do well now, is develop ways to mine poor ores. Just imagine what we could do with that technology if we had it now. If you were to take humdrum soil, you know, with not much concentrations of this, everything would be there but not concentrated, and get out what we want, then any country on earth would have all the resources it needed. So if we could develop poor ore mining technology now, that would be an enormous benefit here on earth, and we'd have lots of customers. One of the things I've always been concerned about is that, you know, there's the rush to get back to the moon. So we get there. Then we're going to scratch our head for 50 years wondering what we can do. So we need to figure out what are the technologies we're going to need on the moon. Poor ore mining, processing. Glass composite seems to be a promising material that we can make on the moon. So far we've made ice cube samples of it and determined it's twice as strong as steel, so what? But we haven't done any made enough try to fabricate with it. We don't know. We think we know how to fabricate with it, but nobody's tried. Well, why not figure out, if we had that technology here, what could we do that would make us money here? Develop it now, then we get to the moon, it's on the shelf, ready to go. And nobody is doing this. NASA won't do it. When we get there and they finally decide, after we've been there for 20 years, maybe we should be doing this, then there'll be a crash program that costs billions of dollars. Why? When we could be doing it, make a lot of money on it meanwhile. So
Let me suggest another technology, which is chemical processing that doesn't use water.
absolutely. Absolutely. We need to learn how to do things without using tremendous amounts of water, and what reagents we do use, we need to recycle. So there, mining, manufacturing, processing, all of these things are going to have to be done differently. And there possibly are applications of that technology which would be very useful here. So I am not one, I never talk spin-offs to anybody because people say, oh yes, I appreciate all these things, but I don't miss what I don't yet have, so you can stop now. What I'm concerned about is spin up the things that we can learn to do now and make money doing it so that we've got the technology on the shelf, paid for by the consumer instead of paid for by the taxpayer. Yes, it's the same people, but when it's paid for by a consumer, it's paid for willingly. When it's paid for by a taxpayer, it's paid for reluctantly. We talked about poor ores. There's many things on the moon that we're used, that are there only in parts per billion, like lead, silver, gold, platinum, copper. Imagine how it would be without copper. I can do without jewelry, but man, platinum is now involved in about 25% of modern manufacturing processes. Well, the parts per billion, how do we process something like that? Well, if we ever get nanotechnology, we may, using bacterial cultures to concentrate is one thing. But shouldn't we be looking for submarines on the moon? Anybody not know what I mean by that? Anybody here of Sudbury, Ontario? North of Lake Superior, well, east of Lake Superior, Lake Huron, Michigan, where they come together. A couple billion years ago, asteroid hit this area and apparently was copper and nickel rich. And this is about the richest concentration of copper and nickel on the planet. I think we ought to go over all of our remote sensing maps and see which kinds of instruments pick that up. I mean, they'll all see the impact area of Sudbury, but what have identified it as special? Do we have any instruments that have picked it up and identified it? If we do, let's fly those around the moon and see if some of these craters might be Sudburys. Because that would make an enormous difference in the pace at which we were able to industrialize. We have the things to make concrete, fiberglass, glass, fiberglass reinforced glass, or glass matrix, ceramics, cast basalt. We have a lot of things, but we don't want to be stuck on the moon in a new Stone Age. Flintstones too. We need to be able to do modern, sophisticated technology. And if we have to import all the strategic materials like copper and zinc and lead, whatever we need from Earth, or wait until we can mine them from asteroids, that's going to really hold back lunar settlement. So that's one of the things I think we need to do is that. I think lava tubes, if we build a site near where we have access to, we may not want to build our settlements in them right away, but they're ideal for, what I say, for storage, for warehousing, for industrial parks, because they're all shielded. We know that we have them for sure. Hadley Rail seems to be a collapsed lava tube, but the greatest proof, I think, is visual, and you can see it on photographs very clearly. When we look near side, there's a rill, Hyginus Rill. And if you look at it, you'll find breaks in the valley. It's a winding valley, it stops, and then it continues a little further on. Those interruptions can only be parts of the lava tube that haven't collapsed. And we think that there are many of them. Lava tubes, how many have ever been to a lava tube? Okay, 2. I have 2 near Bend, Oregon. On Earth, lava tubes are a few meters, maybe 30 meters at most wide. That's rare. And maybe a kilometer, a couple kilometers long, not too big. We find them in 2 places where there are sheets of lava, like the great sheets of lava that you find in Northern California, Oregon, Washington State, some places in India. We also find them on shield volcanoes, not the volcanoes like this, but the ones like that. Mauna Loa, Mauna Kea, the big island of Hawaii, is just laced with lava tubes. It appears that on the moon, because gravity is much lighter, that the scale of these things is immense. Hundreds of meters across, could be even hundreds of kilometers long. And they form in the process. That's how the lava sheets flow. The top of the flow freezes and forms the ceiling, and then eventually the lava that's running through runs out at one end and leaves the cave. Well, I think these are going to be very important things to have handy, and don't find them near the poles, because both poles are highland areas. We do need to go to the South Pole Aitken Basin, and one thing that's about this is maybe the biggest impact area on the moon. But unlike the impact areas on the near side, which became flooded with lava sheets sometime after they formed, this did not happen on the far side. And the reason why seems to be that the moon's crust is substantially thicker on the far side. So the magma underneath the crust had farther to go up to reach the surface. It reached it only in a few places. There is an area of the South Pole, there are a couple areas in the South Pole Aitken Basin that do have Mare sheets, but there's small areas really low. Mare and Janie, for example, it's the biggest one. And that happens to be at the antipodes of Mare Imbrium, which is the biggest single basin on the near side now. There are a lot of things we want to do on the moon. We want to be able to go everywhere. We don't want, why spend billions of dollars to design something that can only work in one place and doesn't give you any access anywhere else? If we have a South Pole base, where can we go on excursions from that? Only as far as we can get in 7 days, because in 7 days we've got to get back because we can't stand the night. Doesn't make sense. To me, it is a trap, and the advantages are illusions. Any questions? Yeah.
Peter, what do we know about lunar uranium and other radioisotopes?
We haven't been able to detect uranium directly. The sensors they detect thorium. And there appears to be a lot of thorium, especially on the near side, the Mariam area, the near side Mariam. Some on the far side around Mariam Janie and Van de Graaff there. I think this is a very important resource on the moon. Thorium, whether we find, usually there's uranium where thorium is. But even if there weren't, we know that we can run thorium through a fast breeder reactor and get uranium-233, which is fissionable. Now let's say the environmentalists were to succeed in a global treaty banning shipment of radioactive materials through Earth's atmosphere. Well, you know, we can explore Mars with chemical rockets, but we will never settle it that way. It takes too long, and we'll never get much further than that. We do need nuclear rockets. Well, even if there was such a treaty like this, we could ship the unfueled engines into space and then fuel them up with nuclear fuel made on the moon. In that sense, the moon could be absolutely vital to opening the Mars frontier settlement. And I'm sure, yeah.
What's the possibility of tourism?
What's the possibility of what?
Tourist bases on the moon.
Tourism.
The pole is a very beautiful location.
I personally, you know, there's the moon, Mars, and beyond thing. I have not seen one single example in the whole history of space movement where something decided through political processes made sense. We have a space shuttle that was supposed to be reusable. It's overhaulable, it's not reusable. It was supposed to provide cheaper access to space. It provides the most expensive access to space. We've got a space station which von Braun wanted as a depot, as a jumping off place to the solar system, but it's not an equatorial orbit where it needs to be for that purpose. It's in a high inclination orbit, which is ideal for observing the Earth. It's in yo-yo space. We go up and we look down. It's of no use going out. It's a bad place to assemble spacecraft that we want to go out. But in a way, I think it's good that the government put it there because we need another station. And we need it in equatorial orbit, and that's a commercial opportunity and a tourist opportunity. Right now, it costs a lot to get to space. $20 million if you want to go to ISS. Pretty soon, I think, we're going to see tourists go up to get their astronaut wings, you know, in suborbital flights. And as the market develops for this, the entrepreneurs are going to find a way to get us to orbit. Once you have a craft that can get you into orbit, all you have to do is refuel it and reprovision it for 7 days. And you can loop the moon. And, you know, people think, gee, we get to orbit, maybe in another couple of decades we'll be going to the moon. No, right away. We can loop the moon with passengers, tourists, before we will be able to afford to build a hotel in orbit. Skimming 50 miles over the far side on your loop, that's going to be something. And this is going to whet the appetite for more. The next step is self-contained landing missions, just like the Apollo missions. They bring everything with them, take everything back. No land installations at all for tourists. Then the demand will be there for places to go on the moon. So whether or not the government has an outpost, eventually as tourism accelerates, this is going to be something that will happen. And you put a first expensive hotel made on Earth on the moon, and as demand goes for more space and more places to go, some of the entrepreneurs are going to say, hey, let's build this out of lunar material. And what I'm sketching out here is a scenario where tourism takes the lead that eventually starts industrializing the moon. It seems far-fetched, but personally I think it's more far-fetched that we will convince taxpayers to give us a joyride to the moon. Called Helium-3. And somebody introduced me to him and said, you ought to run your ideas by Peter Koch. So he sent me a non-disclosure contract and then sent me a 50-page synopsis. I wouldn't touch that with a 10-foot pole. And yeah, he had prisoners going to the moon, and what was really objectionable to me, he had AIDS victims going.
Oh,
And I mean, the guy, it was absurd. And the whole idea that you had to use the dregs of humanity, and there was objection to me that he considered AIDS victims the dregs of humanity. But he had used the dregs of humanity to go to the moon because it was so unattractive and everything. Well, how are we supposed to enthuse people to go to the moon by creating that kind of picture? That's one thing. But when we have a settlement on the moon, we are going to have people who are antisocial. So putting somebody in prison is really unproductive, you know. But we need roads built in the boondocks. We need this done and that done, so we'll give them the unattractive jobs. We may have trouble getting people to go out to the asteroids and do what we need. Okay. Put them on the ship, give them the tools. Don't have to send any wardens. They have to cooperate with one another if they're going to survive. And this is what happened in Australia. You know,
Or are you saying you object to the whole concept? Is that what you meant a while ago? You object to that?
no. What I objected to in this particular movie script was suggesting that the only way we could get anybody to go to the moon was send people there and sentence them there. But, you know, wherever we do go, there are going to be unattractive assignments. And if we have to remove people from the stream of society to protect them, we can just assign there productively, and either they cooperate with one another and get the job done, or they don't survive, you know. That's possible, but I don't see that as the main way, the main thing, you know, that we do that on the side.
So you mentioned lava tubes for use in habitats and other things, and I've heard all of that before. But how difficult is it to actually seal something like that? I mean, if you're talking about a 100-kilometer expanse of this lava tube, isn't it pretty likely that there's going to be parts that aren't going to be sealed or open to the air?
Right. I think at first we are just going to use them as shelter and put inside there inflatables or something like that that will contain things. So an attractive idea is we can put an inflatable there with a thin skin because we're not worried about meteorites hitting us. We don't have to shield it directly with anything. So we just need a small shaft to get something through and then blow it up when we get in. Yeah, if you're an artist or you want to imagine the far future, you know, you can create a pretty picture of a sealed lava tube. Yeah, how long is it? And we're going to have to create walls to seal it. The chances are the surrounding bedrock is fractured. But that might not be a problem because if you were to seal it with air with moist water vapor content, the water vapor would work into the cracks, freeze, and seal it. As long as you kept the temperature fairly constant so you weren't having a migrating ice thing with thaw cycles which would keep chipping away at things.
So also, because all the volcanism has been dormant for like several billion years, I mean, so these lava tubes would have to have been in place several billion years ago.
Well, yeah, they all seem to have been formed in the episodes of lava flooding. You know, the big impact basins formed maybe 3.8 billion years or more ago, but the flooding episodes seem to have happened several hundred million years after that, and not much material since, not much since then. So all of these things that are intact have been there for 3.5 billion years.
So I've talked with some other people about the lava tube idea a little bit, and it seems that a bunch of them thought that given this several billion year old, it have to be several billion years old, that due to the cratering processes over these billions of years, that all the lava tubes basically have been smashed and filled in.
Well, that doesn't seem logical to me because now some of the Maria, they are very shallow. You can tell as you look at Mari Smithy or Mari Marginis on the limb, this side, you see a lot of crater rims poking through the Mari. It leaves a fill sort of shallow. Others seem to be the Mari fill maybe kilometers thick. Well, it wasn't, that means sheet after sheet after sheet. So I think you're going to find them not just below the surface, that's what most people expect, but level after level after level. There may be lava tubes way down. They'll be harder to access, but the very fact that we have in hygienists there interruptions which haven't been collapsed shows that there are now uncollapsed lava tubes. We think that anything with at least 40 meters above the ceiling should be fairly safe. Now, we talk about ice having collected at the moon. There's another far out idea. And of course, it came from me, I like the far out ideas. Let's say a comet hit just above a lava tube, punctured it, vaporized. A lot of that vapor is going to condense on the walls and freeze. It'll be still there. In fact, during the Apollo period, the Apollo 15 orbiter, was looking for hydrogen signatures and things like this, but they only went over that one swath, over the orbits. There were found in western Mare Crisium, something very suspicious, looked like ice. I don't know, maybe they found that lava tube. That would be like winning the cosmic lottery, to have something like that happen. That's possible. Makes a good science fiction story, anyway. Oh.
Can I ask you a question? You kind of, what you said about the polar advocates is that they're afraid of the night.
Yeah.
Your comments are appropriate, but you seem to have the fear of mountains.
Personally, there's the old thing about where are we going to go for vacation? The seaside or the mountains? I'm a mountain man. I love the mountains. I climbed mountains. I'm not scared of mountains. It's a practical issue. How easy is it to build there? If I were to be found guilty of something terrible and sentenced to live my life on the moon, I'd rather have my little cell on a mountain where I have a view than somewhere on a dusty plain.
Yeah. So the other thing I wanted to mention was, there is a serious issue with the temperature variations from that day on your side.
Right. We can't be afraid of that either. If we want access to the whole moon, we have to deal with it. Let's grab the bull by the horns and learn how to do that. Otherwise, we are entrapping ourselves in a ghetto. The unusual, atypical situation at the poles are ghettos. If all we know how to do is handle that, we're in a ghetto.
We might want to do the easy thing first. The question is which is easy. Are there any other questions here?
Getting back to lava tubes, an interesting thing is, people don't realize how long time is. And, they're interested in alien species. Is there anybody out there? Civilizations could have come and gone billions of years ago, or billions of years from now. The idea of something being both contemporaneous and nearby, that's something. So let's say some few civilizations did manage to explore the galaxy in the past. Chances are, if they ever came by, it might not be now, it might not even be recently, it might be a long time ago. If it was a long time ago, it might, there wasn't multicellular life on Earth until about 600 million years ago. So for most of Earth's history, all we had are one-cell things and bacteria and microbes. Well, let's say they visited at that time. They could clearly see the continents weren't going to stay where they were. There could be a lot of mountain building, a lot of erosion. No place on Earth you could leave something that would ever be found. Leave something on the surface of the moon, well, that's exposed too. Leave it in a lava tube. It's the only place make sense for anybody ever visit the solar system, you know, especially sometime in the past, to leave a calling card. It's just a fun idea. I tried to write a novel of it and sell it, but it was rejected. But it was on that concept that they were exploring lava tubes and went around the pen and wow.